let's talk about domain and range. When it comes to domain and range for graphs, I think it's going to be one of the hardest parts of the class for some of you. For some of you, it's going to be super easy. That's one of those polarizing topics that some students find really easy to do and some students struggle a lot with it. So just keep that in mind. The domain we had said on the previous section, that is the x values or the input values on the function, and the range is the output values or the y's. So here they kind of review what that means. And then to do this, we need to review some of the notation that we're going to be using. And interval notation we've done before. Remember how to review that from inequalities if you need to. And then set builder notation. You always write it like this. X such that, and then you give the conditions for X. So that's what set builder notation will do. And then interval notation from previous sections. And then you have some review things here that I do recommend you go over for interval notation. And here you have some of the different things, like if you have this, then you have the inequality, the set builder, and the interval. So those are things that you need to review before going into the section. So this is one where if you feel you need to review this, you may want to go over it, stop the video, just go over them and understand it. But one of the main things is always write the smallest number first. You see all of them have the smallest number first. And then set builder, you will write the variable, like here it's the age. So you write age and then bar and then the inequality. You see? It's the only difference between set builder and that one. And then intervals, we've gone over those before. So notice how they just write age, brackets, and then they write the inequality and close the brackets. When it comes to real numbers, this is a notation for all real numbers, and the interval, which we may not have seen before. It's all the number line. Find the domain of the function. When you're talking about domain for fractions, so basically, this is how you find the domain. The domain can be any real number except for the solutions to the bottom of the fraction. So like if I'm trying to solve this one, it would be x minus 7 plus 7. Always get the bottom. So x cannot be 7. Anything else it can be. That's how you do for every time you have a fraction. You get the bottom, you solve it, and that's the only one that it cannot be in that domain. So here you have a fraction and you have a square root. So that's going to be tricky. But let's start with the fraction on the bottom. So you just do x minus 4 cannot be 0. So x cannot be 4. So that's already one of them. But you also have, when you have roots, and I should more specifically even roots. So like square root, fourth root, sixth root. It doesn't apply for like a cube root, only for even roots. You're gonna solve the domain is solving the inside of the root has to be positive. So you're gonna get the inside of the root and you're gonna solve that inequality all the time. The inside has to be positive or has to be greater than or equal to 0. So if I'm doing this one, it would be x plus 6 has to be greater than or equal to 0. See, this stays the same and I'm just getting the inside. minus 6 minus 6. X has to be greater than or equal to negative 6. Now, because they have it in interval form, I am going to do the graph. I have negative 6 here, and then I have the 4 somewhere here. The 4 is skipped. So basically, it's all of this, and then you skip the 4. So it's going to be, this is brackets because you have an equal. The 4, because you're skipping it, you put it in parentheses. And then, so it's going to be this one. When you're skipping the number, for the fraction, you do put parentheses. For the square roots, it is the bracket for the numbers. Here we have a fraction. For fractions, you always get the bottom and you solve it for x. Now, what the problem with this bottom part is that it's a quadratic. So we're going to use quadratic formula. Or factor, if you know how to factor. Now, the quadratic formula is in your formula sheets. So x cannot be the answers that we get. I think that's what you get from the quadratic. So even if you get several answers, you still put cannot equal and just write the answers down for fractions. Now when it comes to graph, you're going to do domain. You read it from the left to the right, and the range, you read it from the bottom to the top, not from the top. Ah, come on, get back here. Come on. There, not too small. I don't know why it's not. Is it because I'm using both hands? What's happening? There. Yeah, to the top. Okay. We'll have to pause and see if we can fix it. So I want you to do it from the bottom to the top because that's where you're going to start reading. From the smallest y up to the, that's how you're going to write your answers. So these are some of the parent functions and their domain and range. It is important that you know them. The better you understand the domain and range for the parent functions and the shapes, the easier it is going to be moving forward. So for later sections especially. So here you have the parent functions with their corresponding domain and range. Let's just pick one here to help us. Let's pick at the absolute value here. So if you're trying to find the domain, you read it from left to right. See how there's an arrow? What does that mean on the left then? That it's negative infinity. And where does it end? Well, there's an arrow on the right. So it's from negative infinity to positive infinity. Now, when you're doing the y's or the range, where does the graph start on the y values? From the bottom to the top, right? Where does it start? It starts right here. So it starts at the 0 mark. And where does it end? Well, there's arrows, which means it extends forever. So then the range would be from 0 to infinity. You always put brackets on the numbers unless they give you an open circle. So like for example here, if we're gonna do the domain and range, the domain is, this is negative infinity, this is positive. If you look at the axis, where does the graph start? It starts right there, and where does it end? Right here. Because I do have open circles, this ones will be in parentheses. So the domain will be from -6 to 2. Now when it comes to the range, it's from the bottom to the top. So where does it start on the y's? It starts right here. And where does it end? Right here. So then the range would be, now the -4 is in brackets because it has it's part of the graph, and then the -1 would be in parentheses. What is the domain of the function in the graph? The domain, again, the axis. So where does the graph start? It starts right here. Where does it end on the axis? Right here. So it's from 1 to 8. The domain and range. Okay, so for the domain, again, where does the graph start? Right here. Where does it end? Now you're tempted to say here, but it doesn't end here, right? It ends over here. So we're looking at the domain first. So the domain, yes, this is from left to right. It would be from -3 to 1. Now the 1 is in parentheses because of that open circle. Now when it comes to the range, it's from the bottom. So it starts at -5. And where does it end? It doesn't end here, right? Because it keeps going up. It ends on the y's, it ends right there. Now the 4, because it doesn't have an open circle, you still put it in brackets. So that's the extent of the graph on the y. Again, domain and range for this. The domain on the axis, it starts at here and it ends here. So it starts at 0 and it ends at 3. And then on the y's, it starts right here, which is -6. And it ends right here, which is 0. Piecewise functions are functions that are broken into parts, basically pieces of functions that you pair together. And what you see, like here's an example. What you see here, this part here is the domain. So which means for any x that is less than 0, you use this one. For any x that is greater than or equal to 0, you use the second one. Another way to do it is to create a number line and break it up at that number. So anything that falls here, I'm going to use negative on the left, and anything that falls on the right, we're going to use that. So for example, this is my x, right? This is -1, it's over here. So I'm going to use that one. The 0 is right on the dot. So let's go to this one and then we'll come back to that one. The 2 lies right here, so I'm going to use that one. I'm going to use that one. Now when it lies right on the dot, like the 0 right here, that is right on the line, you're going to go over here and you're going to look for the bottom bar. You're going to look for that little line. So that little line tells you which one to use, which is that one. Complete the description of the piecewise function below. Okay. So basically we're going to complete the domain. So like for the first one, for 4, this one, the first one, the answer is 4 if your x value is between -6 and -3. Use interval notation. So -6 to -3. And because they have closed circles, that's why I put them in brackets. Now if I look at -4, it's from here, -3, but it's open circle, so it would be -3 like this, up to this one, which is 1 with bracket. And then finally it's 3, it's from here, now it's an open circle, so I put 2 here, which is, so they're asking us to do the domain, so they're asking us to put the x value. Complete the description of the piecewise function here. So here they're giving us the graphs and we are supposed to put they gave us the domain and we're supposed to put the graphs. The easiest one is the middle one, that it's a constant. This is going to be just 2. So we just put 2 there. The other ones are going to require a little bit more work. So for example, this one here, we're going to identify the points. So this would be 3 on the x, -3 on the y. I'm just identifying the point. I'm not looking at the open circles or closed circles. This is 6 on the x. Maybe that one's not the best one because it's not on the exact dot. Let's use this one. That's going to be 5 on the x and 2 on the y. So what you have to do is find the function that has those 2 points. So it's a linear, it's a line. So it would be finding the slope. It's going to be y2 minus y1, x2 minus x1. 2 minus from the formula and -3. 5 minus 3. So that's 5 over 2. And then we can use this formula. I'm just going to pick this point to use. Y minus from the formula and then 2 equals my slope, which is 5/2. X minus from the formula and my x, which is 5. A lot of times my open math will just agree, let you use this. Get rid of parentheses and then plus 2, plus 2. So you would put here, this is for the last one over here. So you would put 5/2 x minus 21 over 2. And we're going to have to do the same thing for the other one. For the first one, so I'm going to type right it over here. Okay, so the points I'm going to select are this one here, which is -1, -1, and then this one, which is -5 and 5. Those are going to be our points, and then we find the slope. So that's going to be -6/4, which is -3/2. And then we do y. I'm going to put these. This is going to be my x1, y1. And slope, my x. Minus 15/2. Then plus 5, plus 5. So it'll be y equals -3/2 x as 5/2. And that's what we would put here, not with the y, just the 3/2 x minus 5/2. So these do require a little bit more work. The next one is sketch the graph, and my open math has its ways to do sketching. If you have any problems with sketching, I can make a some video about how to sketch with my open math. Basically grab these examples and actually graph them on my open math for your homework. But like here, -3 for any x less than -2. So look at the -2. This is where we're gonna break the graph. So what we're gonna do, let me do it in red, that way we can see that. It just feels like it should be in red. -2 and 2. That's where we break them up. I'm using this. Okay, and then we just graph what we have. Like the first one is -3 right here up to here, and then you see here that it has an equal on the bottom. That means I'm gonna bubble it in. Then the next one is 2x plus 1. So that would be, you can just select points. Like if you put a select points for like -2, 0, and 2. And then y is 2x plus 1. So that would be 3, 1. So I'm gonna just plug them in. 2, -3. And then, so it's gonna start where I ended. 0, 1, 2, and 5. Now if you look at the 2, here it has the equal, so I'm gonna bubble it in. I'm basically gonna do that. And then after that is just 4. Here. Now because the 4 doesn't have the equal, we're gonna put an open circle. Some additional examples have to do with domain. Find the domain of the function. What is the only value that is not in the domain? You grab it from the bottom and you solve. So they want to know just the value that cannot be in the domain. So you just solve the bottom. And this is the only value that cannot be in that domain. For the square roots in their domain, you get the inside. And you always set it up greater than or equal to 0. And then you solve the inequality with the rules of inequality. This is just in inequality form. They want interval notation. So it would be 15 to infinity. Now, when you're trying to find a domain for something like this, again, the x's, where does it start on the x and where does it end? It starts here and it ends right there. So the domain of the function, it doesn't say what, so I'm going to write it in interval. -2 to 1, because the 1 doesn't have an open circle, I'm going to put it like that. Now, when it comes to the range, where does it start? It starts here on the y's, and where does it end? Right there. So it's going to be from 0 to 4. And then this one is evaluate. I like evaluating by creating a number line and breaking it up at the number. So anything that falls here is this one, anything that falls here is this one. So like the first one is -1, it's right here. So I'm going to use that. I'm going to replace the 1, the x, with a 1. The 0 falls right on the middle, so if that's the case, you're going to look for the equal. That one right there, so I'm going to use this one. And then the 2 falls right here, so I'm going to use this one. So I hope this helps for 3.2. If you have any questions, please let me know, and I can show you more examples of anything that you're struggling with.